academic councils as well. He has been a visitor's nominee, that is, a nominee of the President of India for IIT Kharagpur and IIT Bhubaneswar. His contributions to the advancement of engineering education and research are really commendable. May I now request Professor Tarkeshwar Kumar sir to kindly take over the session. Thank you and over to you, sir.
Okay, thank you, Tanika. So if you allow me, I'll just share my screen. Okay, Dhrubajyoti.
Yes, sir. You
Okay,
can share, sir.
right. Yeah, please
Yes, sir. It is
confirm my
visible.
yeah
Visible, sir.
screen is visible and I'm also audible, both.
Yes, sir. Yes, sir.
So thanks very much to give me opportunity to speak before the August gathering of honorable teachers and my dear students who have registered for this 5 days course. And it's my privilege to speak before you for about 2 hours, including discussion, etc. And I have the slides which initially gives you a profile of petroleum engineering exploration, production, and processing as such. So that will give you what are the operations that are going on and what are the challenges that we face in the petroleum industry. So first of all, we like to draw your attention about the energy crisis, which is a term which was used long time back. But however, this term has not vanished from our day-to-day life, as the requirement of energy has been growing day to day, particularly developing countries. To improve our quality of life, we need energy, and the supply of energy is always limited. Oil industry is forced to work for oil recovery in complicated areas. This is another dimension that we will be seeing, that the easy oils have gone, so therefore the newer fields and discoveries are very difficult to make. So those are challenges. The oil industry, which is making the hydrocarbon energy available to us, so they are facing problem. And so these problems of oil recovery also will be discussed. In primary and secondary recovery phases of the industry, only 20 to 30% approximately of original oil in place can be recovered. And therefore, there is a need for improving the recovery by so-called enhanced oil recovery or improved oil recovery, where additional expenditure is involved, which again puts pressure on the oil industries. There is a need to improve tertiary recovery, what we call enhanced oil recovery these days, for improving the recovery. And now this improvement recovery in terms of percentage, target can be as low as 5% and as high as 40 to 50%, depending on what was percentage of the saturation of oil was left after completion of the secondary recovery. Now let me just tell you that the secondary recovery here refers to mostly water flooding, and that is adopted after primary recovery by natural energy. And water flooding is done in most cases, but in some cases it may not be necessary. And that is also one reason to explain to those who are in petroleum industry to why the enhanced oil recovery and not tertiary recovery. Because if you are going for tertiary recovery after primary, then people may ask, well, where is secondary? So the tertiary recovery is a term which has been now replaced with enhanced oil recovery, which can be after primary recovery or it can be after secondary recovery, depending on the need. Or different developing technologies, depending on the requirement of a particular type of reservoir, rock characteristics, and the fluids contained in them. So the need has to be evaluated, screening criteria has to be applied to apply a particular method. So different technologies are there and those are actually applied. Now, before we proceed to those, let's again come back to this energy concept. What is the requirement of energy for our citizens? Ensuring lifeline energy to all its citizens at all times and at an affordable cost, leading to energy independence, is termed as energy security. Now, in order to achieve energy security, the multi-pronged action is required. Some of the actions are direct, for example, use of least energy to provide services with the available sources of energy. And as a matter of practice, we should put effort to cut any energy losses that happens in the entire energy chain system. And third concept is that you don't really have to concentrate only on the major sources of energy. As a comprehensive approach, we should try to have or secure access to all forms of energy, no matter whether it is small or big. For example, bioenergy or rural sources energy, bio-waste energy. These may be small sources, biogas. So, energy from waste, they call it from paddy field, from wherever. So, major sources of energy, whether it is renewable sources, not renewable sources, or from a rural background source or from urban background source, from agriculture source, from other industrial source, all forms of energy in all proportions should be utilized in order to provide complete access or maximum access to citizens of the country. So energy security has become an important issue for the developing country like India. The strategic goals for energy independence by 2030 would thus call for a shift in the structure of energy sources from fossil fuel to renewable energy sources. And this diagram is a very good diagram for the oil industry's total profile. What are the operations that goes on from upstream to downstream. From the upstream side, we have started from the drilling activities where after exploration, you need to drill a well to confirm its presence and also commercial viability, and then you produce and after separating, making you can say processing it so that gas it becomes stable oil. So stabilization is one aspect, and that is done by separation system. And then if any emulsion is there, using heater, treater. So ultimately aim is to, and also other processing so that it is clear from the undesirable material containing the oil. And once it is ready and acceptable to the refining people, that much pre-processing is to be done. You store it and pump it to the refinery people. Any excess gas that is not commercially available could be also flared, called technical flaring, to very limited extent is allowed these days. And then eventually you have, so it's a complete system of the oil industry's operation for oil processing. Now, what is crude oil? Most of us know about it, but those of you who are not from the oil industry, for them, I should say it is a mixture of hydrocarbons, basically. So it's not a pure substance and varies in composition in different fields. Lighter crudes for more valuable, they are lighter crudes are more valuable as it yields costly products from the point of view of the sales. The revenue earned from the sales of a petrol, diesel, etc. is much more than the other products. So all the products are there, but lighter products which are coming from the crude oils, light crude oils, in terms of specific gravity or API gravity, is more valuable. Now, if you are saying it is mixture of hydrocarbons, then it contains gas as well as oil to some extent. So gas primarily has a hydrocarbon which are having 4 carbon atoms. Okay, so those are called gas, whereas C5 and above are called liquid and also solid. And solid generally C16 plus are coming solids, and in common parlance it is also known as paraffin wax. And most common product that we use out of this gas component is C3C4, what we call as a propane and butane, 50% each by weight, is known as liquefied petroleum gas. And we are all familiar with the household product LPG. Without that, our life is very difficult in the kitchen. So if you see the composition of typical crude oil and gas, we have shown separately. Crude oil composition is expressed in terms of percentage of carbon, 84 to 87%. It can be more or less within plus minus 10%. And hydrogen, 11 to 15%. Sulfur, 0.1 to 3.5. These are called impurities. Nitrogen and oxygen are also present in impurities at 0.1 to 0.5. And some more gases may be there also as impurities dissolve in it. Whereas natural gas composition is expressed in terms of methane, ethane, propane, proportion. Percentage-wise, it is very high. Methane contents very high, anything 88 point. In one typical case has been given here, but it can be anything above 85, 86%. Whereas ethane is in the range of 5.2 plus minus 10%. Propane 3.7 again plus minus, butane 1.8%, and these are the two components go and form the LPG composition. Pentane is 0.5, slightly less. So okay, this is not a gas, but this is a vapor which is present generally in natural gas. Okay, what are the products which you are familiar with? That is, these are crude oil. There are two types of crude oils from the base point of view. What is on distillation, the residue is examined, and if it is paraffin based primarily, it is called paraffin based crude, and if it is a asphaltene based residue is asphaltene, it is known as asphaltene base, and it can be also mixed base. So typically in a refinery process, first process that goes a fractional distillation, which we know already from school days, will yield petrol, diesel, kerosene, aviation gasoline, and fuel oil, which are heavier products, heavy oil, lube oil, wax, bitumen, all kinds of solid to gas to liquid to solid products, which are sellable, which makes, by selling, you make revenue and make profit. Whereas from natural gas also, valuable products are produced for selling, and this LPG we already talked about. Then from methane, we also produce fertilizer, okay, particularly urea and some petrochemicals, adhesives, typically that we use all kinds of adhesive for our day-to-day use, domestic as well as commercial, like furniture industry uses a lot of adhesives in a commercial quantities, whereas in home we use small tubes for adhesives. Synthetic rubber fibers, this is one which is just 2 words, but our life goes around this synthetic fibers. Most of the clothes that we wear or use in the night, wearing, these days, blankets, etc., which have mostly they are these days synthetic fibers, polyester based and all that. Woolen products also there is. I'm not talking about woolen products, other than woolen products. Paint, need not explain much. We know where paint is used, plastics. Life goes around plastics. Everything has plastic. You imagine your product in front of you, in your hand, and everywhere you think of the AC, you can think of telephone sets. You have printers, computers. You know, large part of it is made of plastics. Synthetic rubber, the rubber, all kinds of rubber, although natural rubber trees also give rubber, but its product is yield is so less that rubber consumption by people need to be supplied by synthetic source, that is petroleum source. And the biggest and most attractive product is given here in the center, Vaseline or Imami or any other company which manufactures what? They don't manufacture, they just take it from refinery, microcrystalline wax, and put inside it and just market it to you. And this is very valuable product for our cosmetics. All the cosmetics and most cosmetics have the base of the paraffin only. And this is a pure product. So we are there. Now coming back to our how the oil and gas occurrence of petroleum. In a typical diagram I have shown here, you have a sedimentary rock with the fault has been shown. So a trap has been shown with the fault trap, you can call it here. Oil and gas has been shown here, which is trapped. We'll have more diagram on this later on. So let me say how the oil, for the novice, for the people first time, those who have registered students, non-petroleum people may understand that origin, what is the origin, from where it has come and how it has migrated and how it is deposited. So origin wise, it is believed that the petroleum, oil, including oil and gas, solids, etc., it is of organic source where plants and animal remains in the marine environment under the action of high temperature and pressure, and in the absence of oxygen, very important, forms petroleum. And where it is formed, the rock in which it is formed is normally known as source rock, and mostly conventional oil and gas. Except the shale gas, people say that it is in the source rock itself, but in any case, it has to be sedimentary rock. But when it migrates under the natural hydrostatic pressure difference from point to point in the porous and permeable rock where it was originally formed, it starts moving with time. In millions of years, it finds a new home where it can no longer migrate or move. In other words, it gets trapped. That's the reason why the reservoir rocks where oil and gas is found is generally, geologically, it is known as trap. So why it has been trapped. So subsurface pressure plays an important role in that. And this is where, if you have chance to see like a place like Dubai, because if you are in Dhrubajyoti, and if you are elsewhere, of course, you may not get chance, but this is how one diagram is there, which shows the occurrence of petroleum as seepages and dried, the brown stuff. So lighter oil getting after it has seeped and dried. So you can see the occurrence here. So in other words, the oil and gas normally into the capillaries, we are not able to see them. And all sedimentary rocks are, the pores and capillaries are of the micron size. Now these micron size, typically in a common sense, if you say a common person, you can see a man's hair, man's or woman's, so people's hair. So hair thickness is typically, I give example, that the pore size will be of micron size, but typically size could be of hair thickness size. And the hair also is of capillary type, not the solid one. So inside the hair, if you imagine that there would be a hole in the hair. So that is the kind of range of capillary sizes in which oil and gas could be found. It's very interesting challenge to petroleum engineers to locate this oil and produce from the network of capillaries. There is nothing like a tank in which oil and gas is found. So it's a great challenge to uh, let it move. So if it is a lighter hydrocarbon, it can move. If it is heavier hydrocarbon, it is very, very difficult to move. And that is why more difficult to produce them. And these four diagrams are showing the types of four different types of traps. This is more conventional type of dome, or we call it anticline. Here oil is found in the rock, and there is a two non-porous and permeable rock, cap rock. It is called overlying, underlying. This is how a sedimentary rock in which oil and gas is flowing and has got migrated from hundreds of miles away from where it was formed in source rock in marine sea environment, and eventually in millions of years it has moved, or rather it has migrated and found a home and got trapped here. So reservoir rocks shape is, that is why it is synonymous thing. There is a trap in which oil and gas is found, and this trap is known as reservoir. So there can be different types of trap. It can be also formed by fault, it can be double fault, or it can be surrounding a salt dome also. Now again, people talk about very commonly upstream, downstream, and what is it? And is there in midstream also? Well, initially when the industry was formed, there was no concept like midstream. The company used to explore and produce oil and gas, and then they used to sell it to refineries. So the entire job of making it ready for selling was done by upstream industries, and including the transportation if needed, or it was a partnership between the receiving organization like refineries or petrochemical industries who will buy your oil or gas. But these days, because of the expansion of the industry, so large that transportation and pre-processing and extraction of valuable products, these have become very big business, particularly when it involves a larger context. Many continental places are involved. Many countries are helping us to get gas mostly, and oil can be also from neighboring countries. So if that business is so large that exploration companies are not burdened to supply these two refineries. In between, these businesses are there, whether it is oil business or or gas business. This is handled. So including pipeline and the pre-processing, separating, LPG bottling, all these things can be done. So midstream has been created between the producing company and the processing companies. And the operation is also in offshore or onshore. So this has been tailored in this case. So offshore operation. So although it is part of upstream and can be also part of the midstream built in here, but typically when it is found in water, deep water, then the entire operation is known as offshore, because there is a water challenge that you have to handle. Now coming back to the exploration, how do we find out? People usually used to ask me question when I used to say I am a petroleum engineer. They say, okay, tell me how oil and gas, how do you know about it? I had to be very honest to tell them that actually our friends, scientists and engineers, they are responsible for finding oil and gas. We are responsible to produce oil and gas. So that's the question is how they find out. So this is one slide which just tells how it is found. So seismic survey with reflection and refraction, all of us have read in optics or physics. Principle is there, which has been demonstrated here. So on the geophones, whether it's offshore or onshore, one of the principles is that if you send these waves, seismic waves, it will be reflected from the interface of the rocks, which has different densities. So at the interface, it will reflect, and some of them will also go down, refract, and then again reflect. So this is the phenomenon that happens. But this helps in every point. And if the terrain, surface, or interface is different, then the entire thing can be rebuilt by modeling approaches by geophysics friends, and you can get the shape of the trap and also depth at which the trap is there. So this is very, very beautiful science that we have. But other methods also support them in order to confirm the presence, not only presence of oil and gas, the shape of the trap and the depth at which the trap is there, the magnetic method, gravity method, and electrical resistivity methods. And typically anomalies are found with the average magnetic gravity or electrical properties of the rocks, basically, entire rock, below surface are used for finding depth and type of structure of rocks. That's the main objective. Special vessels are used for exploration offshore. So additional effort is required. So these vessels have to be specially prepared. This is an example of magnetic anomaly where it is a lab data only. You can see the two types of rocks, and if you take average of the vertically or volume wise, it will have a reflection at the surface of the magnetic property, provided one of the bed out of the two, one of the bed is having magnetic property like iron ore or something like that. But gravity is a very common thing. The acceleration due to gravity, from the school days we have studied acceleration due to gravity is g, and which varies from place to place because the force of attraction in the center of Earth will depend on the total mass of the rock that we have, that will have a varying density. So the resultant effect on the value of G will be different at different places. You go to Himalayas, it will be different. You go to any plains, it will be different. So it depends on the total density of the rock below that, up to which you want to see. So this is another property which is used simultaneously. Okay, these are only backgrounds. There is no objective here to teach geophysical methods. Then this slide shows a little bit expansion of that upstream operation, which is seismic survey. So exploration is also part of the upstream business. So seismic surveys, processing and analysis, developing a prospect for exploratory drilling, okay, is part of exploration. Exploratory, so developing a prospect by studying sort of thing, and then actually drilling wells during exploratory stage, including logging, open hole logging or wireline logging that are done by our geophysics friends, and many other tests also done. So this is generally coming under that. Then some production tests by well testing engineers also there to support the analysis of the data obtained during exploration. And if it is all successful, we say we have got discovery. So we declare it as a discovery of the property. After that, then more systematic approach is done to drill more wells in the whole property so that the production in long time will become commercial. So this is activities known as development. So you have to have the appraisal and commercial productions during this stage, and also expand with a more systematic scientific manner in the development of the field, creating all kinds of infrastructure, not only wells, but also pipelines, network of pipelines. And I gave you one slide where entire surface facility like separator, heater, treater, treatment facilities, sand treatment, and fines treatment. And ultimately you have to have a clean oil and gas going there. Even gas is also treated to some extent. Okay, so the production phase is purely a production activities where every individual wells operation in terms of production rate is focused. Their monitoring is done, rate is monitored. If any sickness is there, it is serviced using workover rigs and all that. So servicing of the wells which is under production is part of the production activities, and unless and until it is ready for selling to the consumer. So a pictorial diagram has same thing has been shown in pictorial diagram. You can see in offshore operations there are the platforms here to do that job, and also some ships are also there. sometimes the ships are there, and it can be also through the, it is brought sometimes to onshore, and sometimes it is also processed there. So this is just a glimpse of that. Now coming back to this slide, which is very important, summary of the challenges faced in upstream operation. Okay, so management and information, these two, how to manage the whole operation, because it is a commercial venture. It is not a scientific experiment in the field. It is a commercial venture. Ultimately, objective is to produce the mineral property, that is oil and gas in our case, and profitably, and the information, flow of information should be such that this activity of managing this entire exploration, production and processing industry has a minimum expenditure and maximum profit. So increasing the production of liquid fuels, again this is another kind of decision, because it is a mixture of hydrocarbon. It also contains gas in dissolved form and free form. So as a reservoir engineer, a job is to see how to plan the whole thing, and so that the production is optimized in terms of maximum liquid production. Because if you are selling oil and gas, and if some part of gas is remains dissolved in oil, you are selling as oil, then that will be profitable. But if you have, let us say, other way around, the vapor, liquid vapor is going into gas and is selling in the gas form, then you're losing some valuable revenue, because if your vapor, which would have been liquid produced, would have fetched you more money. So these are the optimization problems, which is also very good engineering approach petroleum engineers do. Sources of crude oil, of course, we need to see the challenge. What is the source? Offshore, onshore, deeper reservoir, high temperature reservoir, high pressure reservoir, and more viscous oil, heavy oil. And then you can think the challenges like low permeability reservoir. Permeability is also not homogeneous, heterogeneous reservoir, layered permeability. So if you are handling those kind of things, there will be a lot of sources of crude oil basically will throw a host of challenges which you have to handle. Similarly, in the surface, if you are having operational problem, or if you have to do some injection of the fluids required, water or gas or sometimes air for heavy oil recovery, then how do you operationally do them? If gas has to be injected at a certain pressure, then compressor challenge is there. So the operational challenge is also enormous. So you have the support system. It is said that more than 80% of the infrastructure that is used in oil and gas industry are actually in supporting those operational challenges, or taking care of the operational challenges. So in other words, the oil industry is not run by only petroleum engineers. More than 80% engineers, scientists, workers, and experts are actually the sister domain, who are providing or who are taking care of the operational challenges in oil and gas industries. So energy demand and supply is the overall managerial approach is there, because ultimately whatever you are doing in industry has the focus on taking care of the energy demand of the country. So sometimes there is a planning commission, government of India or government of any country giving certain targets, and so you have to make your plan change. It is not, this is a typical industry which is not completely profit oriented plan. It's a very interesting thing. This hydrocarbon industry is not controlled only by in-house companies owned board of governors, but also has a national demand. So national demand means the government's think tank also has a say in what will be the profile of meeting the demand of the country. So many a times strategies of the oil industry are changed as per the national demand, not only commercial demand. It's very, very interesting. Most of the other industries are working on the normal demand and supply, but this energy demand and supply is also influenced by national policies. And the universal global problem of environmental challenge in the whole world is also plaguing the economic issues. So you have to make sure that whatever you do, whatever infrastructure you develop, whatever the methodologies that you use of injection and production fluids, they should be always safe. For example, CO2. If CO2 is coming out, you have to make sure that these days. Similarly, you have noxious gases. You have the you have H2S, you have SO2, or besides carbon monoxide, and many other liquids which are effluents which are coming out and which is going to paddy fields, polluted water, produced water may contain heavy metals and other ions which are not at all favorable for the agricultural products and all that. So environmental pollution is an enormous challenge that people have, and I know that simultaneously Dhrubajyoti University is also organizing 2 days conference on water management, where the pollution has been focus of discussion. So we are not discussing here. I'm just only giving challenges as the name of the slide is. Fluctuating crude prices. Well, this is the worst thing that can happen in any industry. As a raw material input in any industry, we have to focus on what can be the prices of the raw materials next 5 years, 10 years, 15 years. Well, crude oil prices are very volatile, and since it is most expensive input to the refineries, processing it, this throws additional challenge on that. Sustaining operation of the refineries also, because the outcome of the product is your petrol, diesel, kerosene, etc., which are used by common people. So there are always a hue and cry that why prices of petrol is going up, why prices of domestic LPG is going up, or CNG is going up, but that's connected with the supply source and the cost of other chemicals and materials which are used for processing. Therefore, it's very complex business, and economic uncertainty is assigned there. This slide I have shown you people to show that there is altogether additional challenges of offshore challenges. This diagram, before I explain the details here, in short, what is the challenge of offshore? The offshore challenges, in one simple way, we can say the water depth itself is a big challenge. So you have to conquer water before you are going below the sea level to find oil and gas. And when conquering water means for exploration, for production, for transportation, for maintenance, for logistics, service system. So entire chain of the oil field operation will be influenced if water depth is more or less. So if it is nearer the shore, where your structure, like here one platform, could be anchored nicely, or it can be sometimes jack-up platform also. And this is semi-submersible and ships. So the cost of operation per barrel of oil is much higher if you have to handle the oil production, exploration and production in offshore with a more water depth. I used to say, summarize the whole thing in 2 words. It will be called, this challenge will be called challenge of water depth. More water depth, more challenge to conquer that water for any operation. So a great thing. And then hazards are also, sometimes it happens, which are very, very deadly hazards. So example of any blowout anywhere, you hear sometimes about blowout. So blowout, whether in offshore or onshore, can cause devastating effects, not only on the entire platforms are burned sometimes. And if we have not had any time given for before the emergency has occurred, so the people's life also are endangered. Many times it has happened. This is one such example of Nakando incident where blowout was there. Okay. There are many other examples. The purpose is not to show many of them. In offshore drilling, of course, one aspect. Drilling, of course, we have problems of a drilling, drilling structure is there, drilling platform is there. So here, you can see that space is the biggest constraint. So from one platform, you have to drill many wells. And then the source of water that we have is all sea water. So to the people who are living there, they have to be sustained with the high cost of living, and transportation is also through helicopters only. You can't think of something going on a ship, it will take 1 month time to travel to 100 kilometer, 200 kilometer. So the cost of operation of offshore drilling, besides the operational hazards, operational expertise, like number of wells being drilled through single operation, piling operation to make the wells stable. All these are shown in this diagram. So, summary of the problems occurring due to offshore drilling is that the environment around the drilling site is bombarded by toxic chemicals, threatened by accidental leaks, spills. Primary environmental concerns associated with drilling site are drilling waste, muds, cuttings, drilling fluids, produced water, accidental leaks, blowouts, accidental or intentional spills, drilling waste such as drilling muds, which if you are throwing in the sea, cuttings or onshore also, produced waste contain both abundant and diverse. These are basically offshore operations, but some of them are also common in onshore. So significant risk to the environment. So environmental challenge and meeting them as per the environmental regulation is an additional challenge. These risks include wildlife development defects, shortened lifespan, and physiological challenges. The life that goes around in the sea should not be adversely affected. The potential of accidental or routine release of drilling wastes can occur through containment failure, runoff, or direct discharge. Many of the toxic chemicals associated with oil and gas drilling are known to accumulate and magnify in the food chain. This poses a risk to aquatic organisms higher in the food chain, such as fish and birds. Natural gas and oil leaks and spills can have extremely negative effects on the natural environment, both on and offshores. Drilling fluid management then on the site has certain responsibility like mud mixing, proper mud mixing, mud circulation and transfer, bulk storage and transportation, solid control, high pressure, manifolds and well control, cuttings, re-injection and systems. Then in the Environment Protection Agency studies shows that a routine discharge of any drilling mud can adversely impact bottom dwelling spaces. These impacts range from burial of species to disruption of basic life, such as reproduction, eating patterns, and lifespan. Toxic discharges from drilling mud may also lead to acute or immediate evident effect in some representative marine species such as scallop, lobster, and a variety of fish. This is only an example. Okay. So these are the drilling operations that has been shown here. Now, if you are in drilling challenges are just named here, we are not discussing much on drilling. is a percussion or cable tool, rotary drilling, hole cleaning by mud, incline or horizontal wells, use of turbo dyna drills, drag, cone or diamond bits, temperature, pressure and water depths, and drilling for presence of hydrocarbon. Depending on the type of rock, we have three different types of drill bits: for hard rocks, for a medium hard, and for soft rocks, drag bits. In offshore drilling, of course, these are the structures we are having. Platforms like jackup, semi-submersible drill ships, three different types. Challenges are water depth, hostile environment, current, wave, and these are the corrosion problems. And the wind, wind can also have effect. Dynamic positioning of vessels, which are ship type, has to be positioned while you're drilling or doing other operations. So this requires special type of vessels. And logistics, of course, transportation of the men and material. So offshore structure accordingly have been shown here. So something on the shallow, very near to shore, a jackup. These are jackups here. Okay, and then as you go away, some jackups are there. As you go away, then you have semi-submersibles here. And the ships also are there. And sometimes in the subsea completion, you can see subsea completion also. Typically, when you're talking about production, we have a self-flowing well, we also call naturally flowing wells. Artificial lift, pumping wells like SRP, ESP, hydraulic, gas lift, plunger, chamber, EUR, IUR, water, polymer, surfactant, caustic, thermal. So these are a combination of all that at different stages of life. These are there. Like here, sucker rod pumping example has been shown, ESP has been shown, polymer flooding in enhanced oil recovery has been shown, involving two wells, production well, injection well, and any chemical EUR where the surfactant, polymer, or any alkaline or foam or these are used. Alcohol sometimes are used. So they typically in a 5-spot pattern, you use or any other pattern also, but here it has been shown like that. The injection fluid is there and it helps in mobilizing oil to the production well. So these are the challenges of the planning engineers for EUR, that how best you can keep this front moving smoothly without having fingering or breaking through early. So that means a lot of thinking, a lot of property of the injected fluid has to be compatible. That means basically you have a mobility K by mu of the injected fluid and K by mu of the produced fluid. So if the mobility ratio is favorable, 1 or less than 1, then it is considered to be most effective here as far as sweep is concerned. And then if you want to have the microscopic efficiency, then you have to have ability of such fluids to reduce interfacial tension or wettability reversal to the favorable condition. So all these are there. So this is a typical water injection. So that part we have finished as far as production is concerned. Then some associated sources are there. For example, people say that what will happen after 50 years? Will all oil and gas will be exhausted? What will happen to our young engineers? People say, okay, you have to switch over to the conventional source of oil and gas reservoirs to unconventional sources of oil. One of the most important unconventional source of gas is known as natural gas hydrate. Natural gas hydrate was known for ages. In fact, it was known from the time the oil industry started, because hydrates used to be causing problem in the gas pipeline when the gas pipeline used to face low temperature, particularly minus temperature. And so part of the gas pipeline used to get choked. So that was a nuisance. But later on, they've discovered huge deposits below the Mother Earth or in the seabed, and realized that if you exploit that, then it will be a source of energy. That is the logic that we have. Typically, you can see the gas molecules are trapped in water molecule case. So this is how the structure is there. It can easily catch fire and it looks very white, sort of solid substance. Then another source of energy is yet to be tapped fully, to some extent in certain parts of the world, particularly in Canada. It has been found that oil sand has been mined actually. So it's not impossible. You could mine it, and the solid hydrocarbon, which cannot be produced by conventional approach, can be then extracted in the large scale retort. So by retort, you could now extract it. So the mankind has been able to do all kinds of things which will ultimately make the energy available to you. And very common already in the practice now is known as shale gas. Shale gas here will mean that gas contained in shale rock. Now, shale rock is also considered to be the source rock in which the hydrocarbon was originally deposited, but because of the low porosity and permeability, it did not travel a long distance. So it got trapped, and with the time, the natural fractures also develop, because of the way the entire shale material got consolidated later on. There is an in situ stress change that has happened this geologists will tell you more. The stress changes that took place over millions of years while consolidating the rock with a change in pressure and temperature. It developed the natural fractures. So they say that in the natural fractures, in the crevices, in the pores, the gases are there. The pores are there. It is porous material. Sandstone, this shale rock was originally found from the fines or fine sands, much finer than the sand size. So these deposits here of the gas is not only in the free state, but also in the adsorbed state, and in terms of the quantity per cubic meter is quite enormous. So wherever it has been explored, they found that by having the appropriate technology, this could be produced. And this is what they have found now. By having a massive hydraulic fracturing, they could improve the permeability around the well bores, the well that is drilled through this naturally fractured system, and you do hydraulic fracturing around it, so that the radial flow around the wellbore is converted into some kind of a linear flow, and you have a good conductivity around the wellbore. From away from the wellbore, you will still have flow, because that is flowing from the larger area, so around the wellbore. So this is the concept of hydraulic fracturing, and with that, it found that commercial success, and today it is a very important source of energy supply in the United States. And in India, of course, we are not in a very mature stage, but we are in an initial stage. Some places the work has started. This is another source. This is called tar sand. Tar sand. So tar sand in Alberta, Athabasca in Alberta, has been found, and this can be also important source. There are two types of material, solid material. One is called oil shale, and another is called tar sand or oil sand. So this is a sand material and shale material with oil. Slightly different, but the operation wise it is non-movable hydrocarbon oil contained in the heavy oil, viscous oil contained in either in the sand or in the shale form. So these are the unconventional sources of hydrocarbon for a larger, there is a limited extraction is going on, but in future, wherever such types of deposits will be there, maybe it will be available as a good source of hydrocarbon for people. So I have now quickly gone into more operation wise, and I divided into basic drilling problems, reservoir properties, sweep efficiencies, and flow assurance problems. So this will highlight the more operationally. So the flow assurance, the word you have heard, this is of recent origin, last 15-20 years. Initially, people thought of individual problems, but anyway, basically the oil and gas wells, when it is producing, it should be producing without any hindrance. That's why it is known as flow assurance. So you give assurance to remove hindrance of production into the wellbore. So this hindrance can be of many types. It can be corrosion products, it can be paraffin, it can be wax of any type, and it can be scales. So maybe solid deposited around the wellbore. So all kinds of formation damage related problem, and the well tubing problem. The tubing is getting choked. All that together we can call it as a flow assurance subject. So you have to solve this problem. So wax, asphaltene, inorganic scale, sand, mixture of these. Sudden formation of hydrate in the well, gas well, can be also part of it due to low temperature. As I was telling, in the initial stages of the industry, this was a major problem. And now they have resolved that. Lack of reservoir pressure required to move hydrocarbon to the receiving facilities. Increased pressure drop caused by the high viscosity emulsions. So emulsion problem between oil and water. If it is enormous in the well itself, then this is also part of the flow assurance. Restart difficulties due to heavy and viscous oils. Corrosion problem due to presence of acidic environment and hydrogen sulfide. So this diagram is just, whatever you read and whatever you see, seeing is believing, people say. So have a look at these two diagrams, which will give you a real feel of the two problems of flow assurance here. Choke formation, okay, by paraffin deposition. So you have the pipe here has been choked due to paraffin deposition, has been shown here, where the diameter of the hole has been reduced substantially. It can be complete choking also. Pipeline can be plugged completely or partially. And this side is hydrate shown. So hydrate formed in the pipeline. So hydrate formation in the gas pipeline usually is it is a nuisance and it is a problem. Okay. So according to the problem that exists in a given situation, the solution also have been formed. So general solution for flow assurance are regular injection of chemical inhibitors or solvents, regular launch of pigs or displaced through pipeline, injection of hydrate inhibitors, appropriate selection of pipeline diameter or flow control, valves or chemical products, usage of emulsion breakers, sand control or regular pigging operation, use of pore point depressants. So in a research subject, you could take up one or two problems and try to solve and find out the solution of a given problem. Optimum thermal insulation or active heating, use of corrosion inhibitors, pigging or internal coating. So these are the possible solutions. Now coming back to one stage, we said a substantial amount of oil and gas has to be really, it's not only enhanced oil recovery, enhanced gas recovery is also possible. For example, if you have a CBM gas and or even in natural gas, a substantial amount of gas is remaining and the pressure has depleted, then you could try enhanced gas recovery. So enhanced oil recovery, typically we are saying enhanced oil recovery, but enhanced oil and gas recovery would be a better term. So worldwide statistics wise, okay, EOR projects, if you look at mostly find thermal, most of the oil, enhanced oil is coming from thermal projects and a substantial amount of about 40% from the gas method, gas injection method. and chemical method about 11%, and rest is micro 0.6. This is one type of statistic. Slight change here and there taking place. And in this, this is another diagram which shows slightly more details given. For example, if you're talking about chemical one, then ASP, okay, alkaline surfactant polymer flooding, very complex chemical flooding, a small percentage because of economics. And only polymer flooding, more popular, is there 8%. Gas immiscible, where the front is not miscible, is about 6%. Gas miscible is more popular. Out of that, CO2 or hydrocarbon gas, enriched gas, for example, is a substantial amount of projects are running. And in the thermal method, of course, here is steam thermal method is most popular all over the world. But there are hot water projects, small percentage, and there is a in situ combustion method, which is also running in some places. So general understanding, this is not exhaustive screening criteria, but I say that you have a just basic understanding of screening criteria. If you look at the depth here from shallow to deep upwards, and x-axis is oil density. So if you have a low density, that means light oil, and occurring at the shallow, relatively shallow depth, so this green circle shows that surfactant polymer has been more popular in that. But there is also interface. It is not that the polymer cannot be used in a slightly deeper well, but this is a statistical data. Similarly, if you have a high density with high viscosity, steam method has been very popular. And miscible gas, because of the miscibility of the gas for miscible flooding, finds more suitability in the deeper formations. So this is overlapping also to some extent. Now just a name of the methods that are used in enhanced oil recovery and where it applies: alkali method, surfactant method, polymer method. Alkali surfactant polymer, or simply alkaline surfactant polymer, ASP. Synergistic method. Each method has its own advantage and economic success possible. Surfactant is very expensive, so wherever you are using surfactant, although it assures you complete miscibility and you get the microscopic displacement at very high percentage, but it has to be used judiciously. Its slug has to be designed properly so that you don't use over size slug, or undersize will be question of or the issue of slug integrity will be there. Alkali is known to reduce interfacial tension and controls pH and salinity both. So all the three parameters simultaneously can be taken care of if you are using alkali. So the wettability alteration is also there. So if it is oil wet, it can help you to convert into water wet. So there is another dimension here that many times, many of the alkalis, you have to do lab work, also form in situ surfactants. So benefit of surfactant can be there by simply injecting alkali. When it reacts with oil, it forms surfactant. So these are the multiple advantages. People ask why you are using alkali. So this alkali then has these advantages. And then you have to have alkali slug, you have surfactant slug, you have polymer slug. So if you only have an issue, if you don't have the displacement efficiency issue, simply want to correct the mobility ratio, adverse mobility ratio, polymer flooding is good enough. But these days, in a project, 30, 40 years you have to run. In this project, if you have a clever combination of this, what is called synergistic approach, then in chemical method, these combinations will be working better. But it's not easy to see the economic success. You have to work very hard to get the optimum design, optimum cost, choose the correct type of surfactant, correct type of polymer for a given, alkali also you have to choose. And this is the, again, diagram which for most audience who are not familiar will understand that if you have injection well here and production well this side, then how the fluid will, in a 5-spot pattern, you have 4 injection well and 1 production well in the center. But between a production well and an injection well, how the fluid will be seen. We are talking about slug. So if you are injecting first ASP followed by polymer slug pure and then chase fluid water, then oil bank will be following ahead. So this is part of the design, how what should be the volume of this ASP slug and polymer slug and water slug, so that you don't have the loss of integrity of the slug and you have the continuous microscopic displacement improvement throughout. So you have overall recovery will be higher. So those are the part of the design, and ultimately you produce and process at the surface. And this is a bigger design again from the website and from the text, one of the conventional thing where micellar polymer has been used. So micellar solution can be there, micro emulsion can be there in place of micellar solution. So again here you have a pre-flush to condition the fluid, followed by the slug that you have prepared, followed by polymer slug for mobility correction, followed by again buffer, they call it water and polymer in between. You have a buffer, means it will protect polymer, and followed by large, what is called change fluid, so that your entire slug moves gradually towards the production well. This diagram is good because it is a 3-dimensional cut view and you can easily see 5 wells. Can we look at it? One is here, one is here, one is here, one is here. So 4 injection wells, 1, 2, 3, 4, and a 1 production well. SRP has been shown. Excellent view. Those who are first time they are saying, this will be the diagram to explain how 5-pot pattern works. So from all sides, from all the 4 injection wells, this is how it is in a circular fashion. It is coming from there. Our job will be, as an engineer's job, will be to see that it is not prematurely breaking through. The injected fluid behind should not get fingered. So the plug of the challenge is always that slug that you prepare is moving in the smooth front. The front is not breaking through to the fluid in front of that fluid. So any slug should not break through into other slug. So that would be loss of integrity and then loss of efficiencies. So this is diagram wise looking fine, but its design, its maintenance, volume calculations, these are the challenge. When it comes to thermal method, then heat applied to crude is the basic thing. It is a heat method, in fact. We are applying heat in some means, that is called thermal method. So the primary application of thermal method will mean that it reduces viscosity. So viscosity of the heavy oil having this high viscosity is the target of this heat application. Activate solution gas drive locally, because the gas is also formed, steam is also there and condenses into water sometimes as it is moving. So thermally expand oil will also expand when heat will come in contact. Increase permeability of the oil zone. Create distillation or even thermally crack oil. Cyclic steam drive, heat oil locally around wellbore, stimulate production. In the cyclic steam, where single well is involved. When you drive from injection well to production well, it is known as steam drive. So hot steam is injected in one well and oil is displaced in surrounding producing well. The example is 5-spot. Another variant of thermal method is known as in situ combustion, in which it initiates the combustion of oil in the formation. That means we burn part of oil. And in order to sustain that ignited oil, air is pumped into the reservoir to allow ignition. Heat and gas generate reservoir pressure and decrease viscosity by heating and cracking. That's the mechanism. Diagrammatically also, in the pictorially also, you should understand that this is the method of flooding, steam flooding, where steam is injected here, and ahead of that steam you have a hot water because it gets condensed. This is a cooler zone, and the entire thing is being pushed because you are continuously pushing that steam. So hot oil is gradually getting entry into the production. That's the process. But this process is preceded by a so-called, is also known as continuous steam injection. But it is also preceded in many cases, very heavy oil, with the huff and puff. So where injection occurs for a short time and well is then returned to production after a soaking period given. Another variant of the flooding is known as carbon dioxide flooding, which is now getting popularity globally. In India also we have many projects because it has been found to be very, very efficient. And typically this diagram, you can easily see that CO2 is getting injected here and it forms miscible zone, and in front of that oil bank which is mobilized, and there is a cold oil. So this entire thing is getting moving, and the front is miscible, and therefore microscopic efficiency is considered to be very high. There are conditions attached with that. Three methods of injection is there: pure liquid CO2 in the liquid form at more than 5 atmosphere, followed by water and carbonated water. That can be liquid CO2 going into. So carbonated water, CO2 at sufficient pressure to produce miscibility with reservoir oil. So miscibility is one of the aim. So pressure is a critical parameter in this. Another EOR method is known as microbial EOR. This is also gaining importance. Some of the microbes are very favorable in this process. So this EOR, MEOR is a technology using microorganisms to facilitate, increase or extend oil production from a reservoir. Excuse me for a few seconds. Let me take some water. I think I would like to take 2-3 minutes break. Just hold on. I'll come back. Is that okay?
Yes, sir. Sure, sir.
Yeah,
Okay, sir.
2-3 minutes. Okay, I'm back. So just a couple of minutes on this. The bacteria, should I continue? Yeah,
Yes, sir.
yeah.
Please.
The bacteria which can be mobile or non-mobile have three basic shapes. It can be round, can be rod-like, or spiral type. Some of the diagrams on the right side, these are uh, diagrams of variety of shapes have been given. So any shape bacteria can take. So these microbes are the most primitive or single, celled organisms. And their basic role of life is to recycle the components of living organisms, converting them to nutrient chemicals used by plants in photosynthesis and chemosynthesis. That is the definition. So this this method has been also popular in India. This slide is slightly older, but doesn't matter. It just refers to a polymer flood. I was telling you in some projects, polymer flood in Oil India also, and in ONGC as well as CARE, they have some projects running on the polymer flood. So this is Sanand polymer flood. Some old data is there. Because of mobility contrast and low primary recovery, it was decided to go for polymer flooding. Production increased from 100 meter cube per day to 400 meter cube per day, and water cut was reduced from 88 to 68%, and water cut remains constant for loss till that report was there for 6 years. Very effective polymer for successful polymer flood data was there. That's why I have not removed this, and the project is still continuing and may continue for longer period. Similarly, as I said, Cairn also has some project which much of data I have not given. That's not immediately the objective here. Other projects or ASP projects are also running. In the lab, work can be done. Those of you who have interest in research can see what kind of apparatus is required. So you will require some flooding setup. So this is what is visible here. Sandpack preparation, and second is the core holder was placed in the bench. Okay, here has been found. Vice in the vertical position and filled with 2% NaCl brine. And then the desired sand was gradually added into the core holder. That is the preparation of the sand pack. Finally, the porosity was measured by two different methods, namely weight and volumetric method. Permeability treatment was conducted using Darcy law. So this was done by one of the researchers, and I have taken diagram from there. And this another diagram which shows ASP flooding with a field core. It can be done in the triaxially loaded core holder. Triaxially loaded core holder has the advantage that it can give back pressure. So you could, on the delivery side, you have a disc which holds the pressure. So the pressure at the delivery side is higher, or it can be controlled to a reservoir pressure. So you can do experiment at the reservoir pressure. That is the advantage here. Very special type apparatus. In future, nanotechnology in all aspects have been tried. Electromagnetic heating, improved methods, efficient chemical synthesis for chemical flooding, smart surface active polymer for improving viscous force and reducing capillary force. So these are the basic mechanisms by which future technologies have got backup. For example, nanotechnology is already in use today. Okay, this diagram I will skip as it is only giving some background. Structure of oil and gas industry, those of you who are interested, since you are in India, most of you are knowing it, but students may not have much of idea. There is a industries are exclusively in upstream or downstream, which you are mentioning, or sometimes midstream. These industries, by name, I have given some of them: ONGC, Oil India, KN, Reliance. Uh, they are coming under private companies. So these companies are there under exploration and production for upstream. Whereas in downstream, mostly refining, petrochemical, or distribution, etc. And then some of the distribution companies like GAIL, etc. has come under midstream now because they are handling the gas transportation. HPCL, BPCL, IOCL, RIL, etc. have refineries and marketing. Okay. Similarly, certain regulatory bodies also there. There are many more, but on the petroleum planning and analysis cell, who are preparing on the long-term plans, Center for High Technology, PetroFed, Petroleum Conservation and Research, where energy audit is done. Similarly, for safety purposes, you have DGMS, and for regulatory purposes, you have DGH and OISD, etc. So, on the Ministry of Petroleum and Natural Gas site, details are available. They are functioning and their individual contributions and activities. So process safety performance risk assessment is one other thing which is also important. Plant and process change, functioning of safety critical equipment, competency and training. And unless people are trained regularly, their expertise cannot be utilized maximum. So up to date, latest technologies which are actually prevailing in the industry should be updated to the large manpower. So training is a built-in process. We are the academic trainers, but in-house training is also important, where their activities are showcased in the classroom. And the workers and officers are trained suitably to handle those latest technology that is being used in that company. So that's why we are saying importance of the competency and training. And resources can be financial, staff, or equipment. So latest equipment should be there, trained staff should be there, and you should have a financial, assurance so that business can run. The procedures have to be thoroughly understood. Plant inspection and maintenance is part of the ongoing assurance of long-term business. So sudden failure will be prevented if you have a proper inspection and maintenance plan. If you don't have and you are waiting for the breakdown, people call there is a breakdown maintenance. So you don't go for breakdown maintenance, you should have a preventive maintenance. Releases and near misses, monitoring and audit and review, these are the management jargons. But these days, these jargons are very important because they prevent your unscheduled breakdowns. So we have to understand these management strategies. Okay. Coming back to natural gas availability, which I have not talked so far, and oil availability. In a few minutes I will talk now. Almost coming to close. Natural gas that comes from crude oil wells is typically called associated gas because it is associated with crude oil. Natural gas processing plants purify raw natural gas from underground gas fields and from wellheads from associated gas by removing common contaminants such as water, carbon dioxide, hydrogen sulfide, and processing of raw natural gas yields these byproducts: sulfur, ethane, condensate, and propane, butane, pentane. These are separately sold. It's called value addition technique. This diagram I will not explain in detail. It only says that if you are using natural gas and it is getting produced, it is not supposed to be used directly. Why? Because if you process it, then it does two things. One, all the table here or the chart here shows that it has to be treated so that the purchaser has the minimum difficulties. So you can charge that, you will collect money for that, But if you sell it as it is, then the purchaser or the consumer has to have those plants. And therefore, a consumer may not be able to have all the plants. The gas producing companies who are supplying to many consumers can have a common treatment facility like sulfur recovery, gas treating plants, dehydration, any moisture content in it. Similarly, gas removal, other gas, acid gas, CO2, etc. Okay, natural gas liquid if it is, it's a value addition. The second aspect is value addition. So if you can remove those vapors and convert it to liquid, you can sell it as petrol. But if it is going as it is and burning it, you're wasting. So this is two purposes. One is that treating it, making it suitable for use for the downstream industry or consumer. Second is have the value addition. So some of the valuable products can be taken out. Okay, like sulfur removal also means double thing. One is treatment. Second is sulfur itself can be reused somewhere. Okay, mercury removal is a safety measure, and so these sweetening processes again. So the sulfur components, SO2 and H2S can be removed. So treatment is a two-prong action, making it ready for the consumer. Second is value addition, so that certain valuable product can be extracted before you sell the natural gas. In India, natural gas reserves are shown here, which is it's a good sign that it is gradually increasing, and this trend is still on. I have not shown the whole data. It's available in petroleum site, petroleum ONGC site or DGS site. Sometimes also in the detailed statistics available in Petroleum Ministry of Petroleum site. So this is a good sign of availability. Usage wise, it is used in power generation, domestic purpose, fertilizer, and transportation. Then CBM is another form of gas. Mostly it is methane. This is an attractive prospect for development because of their ability to retain large amounts of gas. Coal is able to store 6 to 7 times more gas than the equivalent volume of rock common to conventional gas reservoirs, because coal surface has an advantage of adsorption. So that is giving that advantage. Coal bed methane or coal mine methane is also known as that. Free gas is known as coal mine methane, is a form of natural gas extracted from coal beds. The methane entrapped into coal cleats in deep or unmineable coal seams is termed as coal bed methane. So usually it's a regulation today below 600 or 700 meters, the coal bed is not being extracted for coal, and therefore readily available permission is given for coal bed methane, that means methane extraction. Added advantage is this gas is a greenhouse gas emission is there, so concentration through CO2 sequestration. So this is CO2. Methane also is a greenhouse gas, but this methane is getting extracted and getting used for energy generation. But CO2 can be used here, I said, as a enhanced gas recovery, enhanced CBM recovery. CO2 can be sequestered. So every cubic meter of CBM can be replaced by that many cubic meters of CO2. So CO2 is getting sequestered, and in effect, you are getting the enhanced gas recovery, enhanced CBM recovery. This is another technique. At a later stage, you can do that. So coal bed methane basically is found in the cleats. Okay, that system of the fractured coal. And the typical well has been shown here, which is required to be fractured like a shale gas. Here also you need fracturing, because around the well bore, permeability is very low. So in order that the gas which is contained as adsorbed gas and also free gas and dissolved gas in the water, the water is getting produced. So you offload this water using pumps here, which contains gas. So gas is to be separated here. That's the basic mechanism. So what are the wastes that is generated in CBM extraction? Is the drilling mud, which is used for drilling. That has to be properly disposed of. Water-based drilling mud most commonly consists of bentonite clay and barite sulfates, so barium sulfate or barites, and calcium carbonate, chalk or hematite. So these materials cannot be disposed of just like that. It has to be properly disposed of so that it doesn't cause any environmental damage. Drilling mud classification based on dispersed system, non-dispersed system. Environmental issues like we just now said that in production or distribution of CBM can have severe impact on rural agricultural communities. So effluent cannot be disposed of in the agricultural fields. In 2006 review began with APA collecting data on the number of active basins producing CBM and their produced water disposal practices. So that is a separate subject of study where how much damage it can cause and how to prevent that. So produced water disposal is an issue that is to be done. So produced water quality varies depending on primarily upon geology of the coal formation. Typically, saltier water is produced from deeper coal formations. So that is a characteristic. Produced water may contain nitrate, nitrite, chlorides, salts, benzenes, toluenes, ethyl benzene, other minerals, metals, high levels of total dissolved solids. Water can cause damage to environment if it is disposed of improperly. Therefore, knowing the quality of the water is essential for planning water disposal and treatment options. This is some statistics where water production has been shown in CBM producing basins. I'm not reading the details data here. It is only showing that a significant amount of water is getting produced, which needs to be handled safely, disposed of. Before disposal, you have to treat them. So in the Powder River, some example is there. Powder River basin, several companies use the option of re-injecting. The produced water can be re-injected into the sandstone aquifer. In an effort to put CBM produced water to a beneficial use, Pinaco Energy is currently re-injecting CBM water into an aquifer. In the San Juan Basin, CBM produced water is typically disposed of by downhole injection. In the San Juan Basin of New Mexico and Colorado, disposal by deep well injection costs around $1.75 per barrel. This figure might have changed. Okay, freeze thaw evaporation technique. Promising commercial technology for produced water disposal is freeze thaw evaporation. Salts or other constituents that are dissolved in water to lower freezing point of the solution below 32 degrees. Partial freezing occurs when the solution is cooled below 32 degrees, but not below the depressed freezing point. So these are some of the techniques which are used for disposal. FTE process has been explained here with only a block diagram, so not much technique has been explained. So you have the feed water, treated water, and brine storage, and freezing pads. So the pump is shown here. So this combination of these activities have been shown here, interrelated to each other. And some measurements, monitoring system is also there where conductivity is measured. Okay, so the freezing pad then is used to finally separate them out. So freeze-thaw evaporation method is reduced produced water management cost, extend injection well performance, expansion of non-conventional resources, beneficial use of treated water and brine, extend production in economically marginal fields. There are limitations of full. This technique doesn't require infrastructure or supplies at limited use. The electricity required is standard 40 to 80 kilowatt and no chemicals are used. FT process requires climate with a substantial number of days with temperatures below freezing. FT process requires a significant amount of land for 35 acres for 1,000 barrel facilities. FT process requires proper hydrogeologic setting including favorable soil conditions, locations of legal waters and characteristics of near surface aquifers. There are other treatments also like aeration, reverse osmosis, sedimentation, chemical precipitation, thermal distillation, road spreading, surface discharge, etc. Groundwater withdrawal is another techniques. In the two potential and serious impacts of groundwater withdrawal resulting from CBM production are subsidence and coal seam. Because CBM, one of the things you might have noticed now, that CBM production is associated with the water production. So for several years initially, we have a huge water production and this disposal. Disposal may be an issue, but the water that you have taken out might cause the ultimately subsidence in that area. And it may also cause coal seam fire sometimes. This has been separately studied by many researchers. Papers are published, available in the literature. And ISM has done several projects on subsidence controlled by our Mining Environment Department. Methane venting, surface disturbance, all these are problems. Of course, uses are many. These uses are similar uses as in natural gas, and can like transportation, CNG, it can be ceramics, steel industry, power industry, fertilizer, cooking, research and development. In Dhanbad is now getting connected through the CNG from Bokaro. So this is also one benefit because we don't have a gas field nearby. Methods for coal-bed methane is a primary treatment. Primary treatment is reservoir pressure depletion, dewatering. Secondary or enhanced treatment, pressure swing absorption and desorption through gas injection. And the recovery of value-added products from petroleum. This quickly I will show you. These products I've shown you beginning. And the type of product can be from the lighter gas to liquid to some solids. Percentage-wise, all find market. And consumption-wise also, production and consumption of petroleum products has been steadily rising over the years. Data from 5, 6 to 12, 13 has been shown. And this is altogether another subject I have shown here, waste oil. Because oil and gas industry handles oil and gas. But do the other people, civilian people also handle oil? Yes. They handle oil in the form of waste oil. For example, transformer or motor oil. So motors are used by everywhere. Transformer is used. So if there is a leakage there or you are draining them out, do you throw them? Or do you collect them? That's a question. So these are called waste oil and is defined as any petroleum-based synthetic oil through contamination has become unsuitable for its original purpose because it no longer can be used for the in the engines unless it is treated. Okay, so that is also one way. Different types of engines or equipment is being used as a lubricant sometimes or coolant. Lubricant or coolant, both are purpose. Waste oil and used oil, these are loosely used terms. So used oil is defined as any petroleum or synthetic oil that has been used as a result of such contamination by physical or chemical properties. Waste oil is a more generic term in any form. Oil that has been contaminated with substances that may or may not be hazardous. Both used oil and waste oil require proper recycling or disposal to avoid environmental problems. Products which are used as a hydraulic oil, transmission oil, brake oil, motor oil, crankcase oil, gearbox oil, synthetic oil, these are different grades, fuel oil, these are there. Many of such same problems associated with natural petroleum exist with waste oil. When waste oil from vehicles drips out, which is common in trucks, lorries, tractors, even smaller vehicles, cars, diesel vehicles, and so the automobiles also has this problem, and these are generally poisonous if you are disposing of in the wrong places, particularly in water source. If you are disposing in water source, then this can be poisonous. So waste oil can be disposed in a different ways, sending the used oil off-site, burning used oil as a fuel, marketing the, so you could use it as a fuel that, and marketing the used oil. Then marketing the used oil is possible if it is again a consumer has a use of selling it as a fuel, or they can retreat and resell it. Another dimension of oil which is associated with petroleum industry is called oil spill, is a release of liquid petroleum hydrocarbon into environment. And so some form of pollution. The term is usually applied to marine oil spills mostly. And this may be release of crude oil from tankers, offshore platforms, drilling rigs, wells, etc. And this may be the totally undesirable effect of oil spill. Now, this is a treatment in one of the diagrams. It shows very nice diagram showing how the oil spill is being treated by coaxial dispersant spread over spill. And this is the containment of the oil spill, okay, by harbor buster. Cleanup and recovery from an oil spill. It's not that always, it may be the oil which is already wasted there in the form of oil spill can be also collected and can be reused. So the bioremediation is one technique that is used by microorganisms. It can break down or remove oil. Oleophilic or hydrophobic chemicals containing bacteria. Controlled burning can effectively reduce amount of, suppose you cannot collect it, it can be disposed of. And dispersants are used sometimes to dissipate oil, so it breaks down. Dredging is used to collect. Skimming is also used. Solidifying is another technique. And oil spill can be, they can be cleaned by changing the physical state of spill oil from liquid to semi-liquid or rubber-like material that floats on water. Vacuum or centrifuge is also sometimes used. Downstream operation is, well, I skip this because mostly here it's talking about refinery and not refinery basically. Here we started with the production of refinery, but many times the byproducts that we are having, those byproducts are available for market. It is part of the entire hydrocarbon chain, so I have mentioned it here. Sulfur recovery, although sulfur is a nuisance, but if sulfur is 2 to 3% or higher in certain crude oil like Dubai crude had, sulfur could be, paraffin could be produced of the oil. Similarly, sulfur could be also produced and can be then valuable product for marketing. So feed gas consumption diagram has been there, how the feed gas can be consumed in this case from sour gas stripper or from amine process, how H2S has been collected here. This is again a flow chain for closed process. I'll skip this diagram. World sulfur and sulfuric acid market. It's not a small market, it's a huge market is there. Sulfur finds in medicine, it also finds in some other downstream products. Okay. Downstream operations have a business joint venture, global refining capacity, corporate communication, distribution activities, crude supply mechanism, health, safety, environment issues, manpower, refinery incapabilities, etc. And in downstream also you have problems which are associated with the spillage that is coming out of any industry. Okay, so monitoring and control is required. So I have come to the end of a brief discussion. Time was quite 2 hours, but now we still have some 10-15 minutes in a question session.
Thank you, sir, for such a
Welcome.
wonderful presentation.
Thank you.
Uh, it was very informative and enlightening presentation. Uh, an excellent coverage of multiple aspects of oil and gas industry. Almost every aspects you have covered, and we have highly benefited listening to you. Participants, if you have any query, you can ask on the topic.
Okay. Perhaps they don't have much of a question. Okay.
So, so thank you, sir. You have so nicely explained about
Welcome. Thank you.
energy security, energy
And for giving
crisis.
opportunity once again for this platform. We have 69
Yes, sir.
people here in the screen. We are seeing it.
Yes, sir. And so may I continue, sir?
Yeah, yeah, please.
Yes, sir.
You can stop
So you
this
have
presentation.
okay, sir. You have so nicely discussed about energy security, direct method of energy security, indirect method, comprehensive methods, which are very significant nowadays, like oil shale extraction, natural gas hydrate applications, tar sands, and also mention about India's strategic goal for energy independence by 2030 and how to meet that objective and the requirement of switching from fossil fuel to non-conventional sources of energy like gas hydrate, CBM. So also mentioned about different products of oil and gas, types of traps, and how expansion of industry has led to the development of midstream industry for pre-processing. You have discussed about geophysical exploration techniques, gravity method, gravity anomaly method, and different challenges in upstream operations, and how to balance energy demand and supply, and how to handle the global issues of environmental pollutions like carbon dioxide, etc., and for sustaining operations of refinery, and water depth effect of on offshore exploration and production, and how costs are involved in this conquering of water depth, and dealing fluid management studies of by environmental protection agencies about flow assurance issues and formation damage issues related to tubing blockage, oil spillage, cleanup methods. So you have almost covered everything, and we are very grateful for this excellent coverage of the topic, and we have been highly benefited by this by listening to you, sir. And before we end this session, so I would like to we would like to have a group photo with you along with the participants. Therefore, participants are requested to kindly turn on their videos for a quick photograph with our resource person. Technical team is requested to take this snapshot, please. So all participants are requested to turn on their videos for a moment so that we can have a picture with our resource person. Thank you, sir. I am very grateful to you, sir. As always, you took time out of your busy schedule to help me in the smooth organization of the program. I am very grateful to you for that. So, actually, lunchtime we'll meet again at 3 p.m. for our next session. Thank you all for your support in the smooth conduction of this program. Thanks a lot.